Example 4, two stationary patrol cars equipped with radar are 5 miles apart on a highway, as shown in the figure. As a truck passes the first patrol car, the speed is clocked at 55 miles per hour. Four minutes later, the truck passes the second and is clocked at 50 miles per hour. Prove that the truck must have exceeded the speed limit of 55 miles per hour at some point during the 4 minutes. Okay, so first of all, let t equal time. Let s of t be the position function. So the position function will tell you where the truck is based on time. So, t equals 0, it would be right here. T equals, 1 minute, might be right here. T equals 2 minutes, might be right here. So on and so on. T equals 4 minutes, it's going to be right there. Let s prime of t be the velocity function. Okay, the velocity function tells you the speed at any particular time. Alright. So notice when the truck passes the first cop car, the truck's going 55 miles per hour. And the time would equal 0. Okay? Since this is miles per hour, we want the time to be in hours. The second cop, when it passes the second cop, it's going 50 miles per hour. The time equals 4 minutes. We want to convert that to hours, so we're going to do 40 divided by 60, which is 1 over 15. Again, because this is miles per hour. Now, we're going to look at the mean value theorem, which states f of c equals f of b minus f of a all over b minus a. That should equal each other. Okay? Well, s prime of t, that's going to be the f of c. F of b is going to be s of 1/15, which would be 5 miles. That's going to be 5. F of A is going to be S of 0, which would be 0, right? At when it's 4 minutes, which is 1/15 of an hour, you would have traveled 5 miles. When the time is 0, you would travel 0 miles. Minus 0 all over b would be 1/15 minus a, which is also 0. So now we got 5/1/15. So let's see, multiply the top and the bottom by 15. We're going to get 75. So 75 miles per hour. That's what this S prime of t should be. Okay, so you know, if we were going to graph this velocity function, it would look like this. Let's see. So time here, let's see, this is that's time. This is distance. Let's see. You'd have a point here at 0, 0, and we have another point at 5. 1, 2, 3, 4, 5. Okay, and then so the slope of this line, that's the slope of the secant line, that should be 75 miles per hour, which means the slope of the tangent line at some point, he should have gone at least 75 miles per hour. So based on this information, we can show that at some point he had to exceed the speed limit of 55 miles per hour.